So this is the question about the toy gun. Number 16, right.
Are you going to post the answer capability?
Yeah. A 9.41 gram projectile. Using a compressed spring with the K value of 1.72 times 10 to the 3, which is, well, 1.72 times 10 to the 3. 13.1 centimeter long barrel. 13.1 centimeters. Okay, Johnny, you should watch now. Okay? As the disc travels through the barrel, it experiences a constant frictional force of 0.13, so the friction force is 0.13. If the spring is compressed for 1.4 centimeters, right? Or sorry, 14 millimeters. What is the speed of the disc as it leaves the gun? Okay. So we've got this spring, we've got a disc, and it's being shot out of this here. This distance that it's compressed is 14 millimeters, and when you convert that to meters, right, divide by 10 for centimeters, for meters, so 0.014 meters. You absolutely positive. If I had my say, I think to graduate from high school, you should have to take a test, and if you can't do metric conversions, you don't graduate.
What about like feet?
I'm sorry that I forgot to.
I can do like centimeters, meters, millimeters.
Good.
Like,
Oh, I know, that feet stuff is stupid, right?
but like the feet.
I
and
know,
all that.
I'm not disputing that. Anyways,
You never learned. Only in
I
this
did
class.
one time.
Only in this class.
Only in this class you
metric conversion.
I did
No, in chemistry we do milliliters to.
Come on, like grade 8 math.
I did a sheet in high school in math one time. We had to go from feet to yards. This,
Yeah, I believe that. I'm positive they teach metric system about grade 8.
Grade 10.
No.
Grade 10.
Anyways. Okay. So when that spring is compressed, it generates or it stores potential energy. All of you want to go and do F equals KX. Okay. No. Stop using that formula.
So when can
Because don't ever use it.
Example.
Don't ever use it.
So like even if we're given like the force and the constant to find the x, we can't use
I
it.
guess.
So there you go.
I have yet to see a question where this formula has led to success for students.
Is that a challenge?
Eh? No, it's not a challenge. It's advice. Okay.
Okay, let's keep
The
going.
spring has potential energy. Okay, and many people got this. US equals 1/2 kx squared. Right?
What's US again?
Potential spring energy. So 1/2 of 1.72 times 10 to the 3 times the distance. Now, which distance are we talking about? The 14 millimeters, which must be in meters. So that's 0.014 meters, right?
Oh, it doesn't make sense.
Look at this. I lent out a calculator the other day. It's got like this rubber thing around it to keep all in place. Some kid takes it off. Like,
Yeah, Johnny, who?
what is it with kids?
I don't know. Probably some grade 9.
Yeah, let's probably read it.
Yeah, I know. You're probably right.
No, there's an attack.
You guys were grade 9 at 1.2.
Yeah, look how much we've grown.
Oh, I know,
I
Talia.
told us that we were full grade 9s and you knew that we were going to be over for grade 9s.
I think I was lying.
I slept
That was like 3 days ago.
Did you get
I
12.04?
was lying.
Did I use that right?
Well,
That feels wrong.
I got a 1 on this question. So.
Oh yeah, you got to square the x, and someone did forget that. I think it was Merv. He waved! I'm going to miss you guys. EXP 3.014
That's a accomplishment for me, okay?
point 16856. Right? Okay. 0.16856. Okay. Now, if there was no friction, what would happen to all of that spring energy? It would all be transferred into
All go into
kinetic energy. And we would just write EK.
equals mv squared over 2
And we would solve for V and we'd go on our day and we'd be fine.
Stupid friction.
We got stupid friction. Okay. So, as this disc slides down, as this disc slides down the barrel, it's going to lose some energy, right?
Because of the friction.
Because of the friction. So how much energy is it going to lose? Well, it's going to lose a certain amount, and it's going to go to heat, right?
Yes.
Okay, so we're looking for an energy calculation, right? Well, there isn't like there's no heat one, but basically all of the energy is going to be all of that heat is going to be because of energy or work done by friction, right? Like when I say work equals FD, work is a measure of energy, is it not? It's measured in joules. And that friction force is 0.13, and it's applied through a distance of 0.1 centimeters, or 0.131. The force of friction is 0.13.
Oh,
You gave it to me,
Yep.
right? So my 0.13 force is doing work as this disk, and this amount right here is going to reduce the amount of kinetic energy I have, is it not? So 0.13 times, one of those doesn't feel right. No, that's right. Times 0.131, which is very odd. So 0.01703. That's how much energy is lost due to
Friction.
friction because of the work done.
Okay,
So what do I do now?
I don't know.
Well, if there was no friction, all of the kinetic energy would be this, right?
Yeah.
But there is friction, so I have to subtract, yeah.
Oh my.
Right, so the EK is going to be the US minus the work. So it's going to be 0.6856 minus 0.01703. Oh, that's not right. No, my calculator wasn't right. Okay, so you're going to get slightly less, right? 0.15153. That's joules of kinetic energy. So now we're going to go exactly. The mass, what was the mass? 9.4. Now that's got to be in kilograms, right?
Yeah.
So that's going to be divided by 1,000.
I gotta write that on my cheat sheet. I always forget that.
Kilo means 1,000?
No, I just, what?
Okay.
Because people are just gonna be like, really? How stupid can you be? So no.
Okay.
Like,
So I'm going to take that number, I'm going to multiply by 2, I'm going to divide by 0.00941, and I'm going to take the square root, and I get 5.7, I think.
5.7 meters per second.
Now, oddly enough, when I did my original answer key, which I've lost, is there an answer key there? But I think there is. I actually did mine using dynamics. I did these first two steps. No. PJ, here's yours here. I did mine by going, where is it? I did mine by finding out, I took that 0.17 and I figured out how much force there was going to be applied based on that work. And then I subtracted friction force. So I did mine a little bit different. Then when I saw Mervin's, I went, oh, I like that. Mervin and Megan's, I think, was the way it was explained.
Yeah, actually.
I was like, oh, I like that. So I changed my answer key to reflect that method, which I much preferred this one. Now, that one and,
The bungee cord one.
well, oh, do you want to see the bungee one?
I don't know yet.
The bungee one has given kids trouble since I've given that question.
You know what? I remember Stan.
So-
told me about this question.
Who?
Cheyenne.
Oh, yeah?
I like how you told me that you doubt that. I doubt that. That's funny.
Okay, so here's the bungee jumper dude.
I
Now-
can't explain why he doesn't get
I have to say that Crazy Eddie was a guy
So
that
did I get the mark? Like,
he is how far above the water? 150 meters. So the first thing you do is you figure out how much potential energy he has. Now you don't use the 100 because how high is he relative to the water? 150. He has mgh of energy. How much does he weigh? What's his mass? 75 times 9.8 times 150. So that was one mistake that a few people made. 75 times 9.8 times 150. He's got a lot of energy, more than I do right now. 110,
Amen.
250. Okay. Now, all of his energy, when he starts to fall, his energy is converted to kinetic energy, right?
yeah, because he's moving.
Because he's moving. But after he's done converting to kinetic energy, all of that kinetic energy has to be converted to
Spring.
spring energy. So can you skip the kinetic energy part?
No.
Yes, because
Yeah, you know,
energy is conserved.
Because energy is conserved,
Heck yeah, dang it, why
right?
did I have
So
this?
all of this, when he gets to this point right here,
Which is what?
which is 100 meters long, that's when the spring starts to stretch. So, can we put 110,250 joules, can we put that energy into stretching the spring without going a distance of 50 meters?
I mean, some of it.
Whoa.
Some of it would go to heat, that's correct.
So just.
Right? So, all of that becomes spring energy, which is 1/2 kx squared. All of this potential energy has to go into potential. How far is the spring going to stretch? 110, 250. It's really quite simple when you are showing the work. What's the coefficient here? The K value?
Yeah.
It's what? 100? Okay. Okay, so we got 110, 250. Half of 100 is 50x squared. So x is the square root of 110, 250 divided by 50. And I think you get like, is it 46.9?
Yeah.
Someone must have got it right.
Yes, yeah.
46.9?
I didn't read it that way, but I got that.
If you round it, it'd be like.
So the spring stretches 46. So 100 plus 46.9 is obviously 146.9, which is less than 150. Therefore, not wet. In fact, he's got a little over 3 meters of room.
When you're going that fast, that's not.
Well, a lot of those bungees, they kind of, your feet go just in the water, and then you come back out, right?
Question just like it on the exam.
That's
You're gonna
pretty
come
cool.
back and he's gonna correct. She's told me like 12 times already this class.
Just because I like.
How she doesn't
And I was
think.
like, gosh, I
Oh.
couldn't do that.
Just time.
Okay, so you said that we can't use the formula F is K. So then,
I
what,
really regret saying that now.
Yeah.
what formula do we, like,
The
what
problem,
instead?
let me go back.